Hey, so today we are going to do an exam style question together. Now, this question is linked to my last video, which we posted, which was on the biochemical tests. And this question specifically is about testing for glucose. So this is going to be the Benedict's test, okay? But it's a 4 mark question, so it's a full kind of written response answer. It says the student wanted to find the concentration of glucose in an unknown sample, but the student did not have a colorimeter. So we can't use a colorimeter, we can't measure the absorbance of light. So it's not going to be about drawing a calibration curve. We need to describe a different method that the student could use where they prepare colour standards. Yeah, and use those to estimate the concentration of glucose in their unknown sample. So first of all, if you want to prepare some colour standards, you're going to have to use known concentrations of glucose. So to get marking point 1, we would say prepare a dilution series of glucose. Now, what we mean by that is in a lab, you're probably going to be provided with a stock solution of glucose, which has a particular concentration. You can take that stock solution and you can dilute it down with water to make a range of different concentrations, a range of different known concentrations. So, for example, if you're given a stock solution of glucose, like a large volume of glucose solution, which has a concentration of 10 millimoles per decimeter cubed, you could dilute that down with water to make a range of different concentrations of glucose. And you'd need at least 5 different concentrations, ideally. If we made this range, so 10, 8, 6, 4, 2, 0, we'd have 6 different concentrations of glucose, which would be sufficient. Now, we'd prepare this dilution series by diluting down the stock solution with water. Now, I'm going to show you an example of how to do this. You didn't have to go into this detail for this exam question. I'm just showing you how you would do it because I know dilution series can be a bit of a tricky topic for some of you. So let's say you wanted all of your solutions to have a total volume of 2 centimeters cubed, okay? Because they all need to be the same volume, right? So say we want them all to have the volume 2 centimeters cubed, and we've been given the glucose solution, which has a concentration of 10 millimoles. We want to make this range of concentrations going all the way down from 10, 8, 6, 4, 2 to 0. We'd have to think about how much of the stock solution and how much water we add to each tube. Now, if we want to use a 10 millimole solution first, and we want the total volume to be 2 centimeters cubed, then obviously we'd add 2 centimeters cubed of the glucose solution and no water. If we want our final concentration to be 0, then obviously we'd add 2 centimeters cubed of water and none of the glucose solution. So they're the easy ones to do. But then all the in-between values, you're going to have to consider how much glucose and how much water. Now, the way that I think of this is if I want an 8 millimole per decimeter cube concentration and I've got a 10 millimole per decimeter cube concentration, this is like 80%. I want the concentration to be 80%. Yeah, 8 out of 10 is 80%. So that means my final volume, I want 80% of that volume to be glucose solution and the other 20% or the other 2 parts to be water. So if I used 1.6 centimeters cubed of glucose and 0.4 centimeters cubed of water, that would give me a final concentration of 8. So I'm using 80% of my volume as glucose solution and the other 20% of my volume as water. The next concentration I want is 6. So the way I think of it again, I'll just repeat it. I want a concentration of 6. I've got a concentration of 10. So 6 over 10. So I want 6 parts or 60% of the final volume to be glucose and the other 4 parts or the other 40% to be water. So I'd need to do 1.2 centimeters cubed of glucose and 0.8 centimeters cubed of water. If I want the final concentration to be 4, well, 4 over 10. So I need 4 parts of my final volume to be glucose, or 40% of my final volume to be glucose. And I need the other 60% to be water, or the other 6 parts to be water. And the rest, yeah, so 0.8 glucose and 1.2 water. Finally, I'll repeat it one more time. This one, I want a concentration of 2 millimoles per decimeter cubed. I've only got the stock solution, which is 10 millimoles per decimeter cubed. So when I look at that, I think, right, I want 20% of my final volume to be glucose and the other 80% to be water. Or I want 2 parts of my final volume to be glucose and the other 8 parts to be water. So I'd need to have 0.4 glucose solution and 1.6 water. So I could use these volumes of glucose solution and these volumes of water to make my dilution series. Then I would end up with a range of concentrations going all the way from 10 to 0, and they'd all have the same volume. Now, you didn't have to include that detail in the answer, just to specify. I'm just explaining how you would create that dilution series. But the point of it is you end up with a range of known concentrations of glucose that you can test with Benedict's to prepare these colour standards. So marking point 1 was to prepare a dilution series for glucose. Obviously, to all of those different concentrations, you would add Benedict's reagent, because this is glucose that we're testing for. So add Benedict's reagent and heat. Remember, to get the Benedict's test to work, you do have to heat it in a water bath at about 80 degrees Celsius. Then you would test your unknown concentration in the same way. Now, we don't have a colorimeter, so we're not talking about absorbance here. We're just going to be relying on colours. So we've used our dilution series, we've tested it with Benedict's, we've heated it. Obviously, then we're going to observe the range of different colours, which are likely going to go from red to orange to yellow to green to maybe even paler green, bluey green. So we'll have that range of colours. But then we're going to carry out the Benedict's test, so add Benedict's reagent and heat. Carry out the Benedict's test on the unknown sample. Now, I actually don't get any marks just for saying this alone. I need to say something a little bit more specific to get the mark here. So when I'm carrying out this Benedict's test, because I want to compare the final colour of the unknown solution to the colour standards that I've produced earlier, I would have to make sure that I carried out that Benedict's test in exactly the same way. So I'm not going to get the mark just for saying carry out the Benedict's test on the unknown solution. But if I say something like use the same volume of sugar solution or glucose solution. So if all of my colour standards had 2 centimetres cubed of glucose solution in there, then my unknown sample, I should also use 2 centimetres cubed of my unknown sample. Or you could say use the same volume of Benedict's reagent. So if I added 2 centimetres cubed of Benedict's reagent when I was testing my colour standards, I should add 2 centimetres cubed of Benedict's reagent to my unknown sample to test it. Because if I change the volume of Benedict's solution, it's going to alter the final colours, and it's going to mean that I can't compare my unknown solution to my colour standards. So I'm really giving a control variable here for marking point number 3. Once I've done that Benedict's test on my unknown solution, I've used the same volume of glucose solution, I've used the same volume of Benedict's, obviously I'll get a colour, and what I can then do is compare the colour of my unknown sample to my colour standards, or to my dilutions, okay? And that's going to help me to estimate the concentration. Okay, so I'm using the word compare, which is really important. Comparing my unknown sample and the colour that it went to the colours of my colour standards that I tested in the exact same way. So for example, if my unknown sample goes orange, and when I tested my colour standards, or when I tested my known concentrations with Benedict's, maybe it was this concentration that went orange. Okay, then I know that in my unknown sample, the concentration of glucose must be about 6 millimoles of glucose per decimeter cubed, because my unknown sample went orange, my concentration of 6 millimoles per decimeter cubed went orange. They look really similar. I'm comparing them. So I know my unknown solution has a concentration of about 6 millimoles as well. Obviously, this is just an estimate because I'm not using a colorimeter, but the question told me that I couldn't. So this is really the best that I can do. I hope you found this useful. If you guys want to learn with me, you want to do year 12 biology or year 13 biology with me, you can click the link in the description on my YouTube channel to get more information about the My EdSpace biology courses and to find one that suits you. And all of those lessons are recorded as well. So if you can't join the live lesson 1 week for whatever reason, you can get recordings of all those videos as well. And all of our lessons have homeworks, we have monthly assessments. So yeah, click the link in the description if you want more info, because I would love you to join my biology crew.